Okay, guys, for this one, you had to find D and F in that order again. So for D, I don't know if anyone else to do it in a shorter way. I first have to calculate that angle over there, and then I use the angle sum and triangle to get D. But if you just look at this triangle, you can see that it's an isosceles triangle. Right? So because that angle is 48, that angle is 58. So it's not really a calculation, just stating that angle CED is 48 degrees because of angles of sides. Then I use the angle sum and triangle to calculate the other thing. Right, this is then 84. And then to get E, I used tan chord theorem. So E is the angle between the tangent and chord CE, but then CE is depending is 84. Right, so that's why E is to 84, which is tan chord. And then on the other side of that tangent, we have F, which is between the tangent and chord DE, but then DE is obtaining that 48 degree angle. So that's why F was 48. So the tan chord theorem, I also said there, know that E is 84. And you could have just used angle sum of, angle on a straight line, sorry, to get it. Right, that would give you the same answer. You would have said 180 minus 84 minus 48 and other than that. Okay? So that's why my second reason is angle on a straight line. You can have either one of those theories. But that's one. Conviction on that one. This work starting to become a little bit not necessarily easier, but are you finding it a bit easier to notice the various theories? Right? I think in the beginning when you just see a question, you're like, oh, I don't know where to start. Okay, but as you practice more, it's a little bit easier to identify. Right? Okay, now for 40, there was quite a lot going on here, so you guys can just tell me if you were able to do it in a shorter way. To get H, let me just quickly check. What did I do? So to get H, I said that D was 46. I'm just showing you first. Right? I used tan chord theorem to say that D is 46 on the side of that line. The angle between the tangent and chord CE is equal to that angle there. That's the tangent by chord CE, so that was D is 46. And then I said that this angle is 92. That angle at center length, right? Angle at the circumference, angle at center has to be double that one. That's where I got 92 from. And then because this is an isosceles triangle, this one here, for the radii, I calculate an angle H by saying 180 minus 92 and then dividing that by 2. So I got 44. Was anyone able to get 44 in a shorter way? This is quite long. It's a bit difficult if there's no mark allocation, right? To know if it's supposed to be like a short answer or a long answer. If it says maybe that's a 6 mark question, then then obviously there's not. But are you guys fine with finding H like that? So first doing time chord theorem, then and working and then working in the isosceles triangle. Quickly, I'll come back to the answers now. Now I had that this was 44. So to get I, what did I do? To get I said that this angle, sorry, this one, between the tangent and chord DE is equal to that whole angle at C, right? Because DE subtends that whole angle, which is 26 plus 44. Okay, so that whole angle there is 70 degrees. Okay, so that is why I is 70 degrees from the tan chord. Right, you can see I put it in red there. So that angle is equal to that whole angle, tan chord theorem. Yeah, and then for G, if you now know that I is 70, then you can use that because this is tangent perpendicular to radius, right? So I and G together, so 70 and G together is equal to 90. So therefore, 90 minus 70. I can write that calculation, but you can add it in if you want. So this to get to 20 was 90. On that one. Okay, I'm just going to move it down so you can see the answers to the next two. Sorry, this glare is very annoying. Okay, you can just write those answers down or just mark and then I'll show you on the picture. So for the next one, you just have to find J, but yeah, there were quite a lot of steps that you had to take in order to get to J. Did anyone do a different method but so after 60 degrees? I'll show you now on the picture exactly what I did for it. Again, I used the exterior angle of the triangle to find the interior angle is on a straight line and the angle is something. But I'll show you now. Quickly on the picture, um, you can still see the answer there. There's just more reasons on the side here. So what I did was I gave us this 20-degree angle, right? And we need to work all the way down to J. So I first say that this angle is 20 because it can fall, right? Angle between the tangent and chord DE, and DE subtends that 20-degree angle there. So that's why that angle is 20. And then I thought to myself, okay, I need to find J, I have that one now. How can I maybe find this angle, which is the exterior angle of that triangle? So remember, yesterday we spoke about this quite a lot. The exterior angle of a triangle is equal to the sum of the opposite interior, right? Like this is an isosceles triangle here. They told us that those two sides are equal. So if you know that that is 20, you can do 180 minus 20 divided by 2, right? To get that angle. Both of them actually. That one also be 80 and that one, right? So I then just used exterior angle of the triangle here because the exterior angle is equal to the sum of the opposite interior angle. So if I have a 20 and an angle, they should add up to 80, because I think that J has to be 60 degrees. Right? One thing that you might have done by accident or because it kind of looked here, maybe not a bit this here is not diameter, right? I don't know if maybe some of you thought, oh, that's a 90-degree angle there because of tangent and because of the radius, but this is not a radius, this is not a diameter. Okay, it doesn't tell us what it's going to be. So we couldn't use a 90-degree angle. Okay. Any questions on that? Okay, number 16. And the answers put on the same thing. So 16 wasn't too bad, right? To get K, I just did answer the same statement, right? Because the K and the 50-degree angle are both determined by that bottom chord. This one here. Right, that chord subtends K and 50. K equal to 30 degrees. Then to get L, I did angle in semicircle, right? Because this line here is the diameter. They showed us that it goes through the center. So that angle is 90, angle is semicircle. And then to get M, I did tan chord. Right? M is that angle there between the tangent and the chord subtends 30 degrees. So M is any questions on that? The 17 was much longer. Again, I don't know if there was maybe a shorter way of doing it. I'll just show you the answers quickly. And you can mark or you can, so that's from here to there. Then I'll click through it now. I'm just going to show you quickly. In 17, I'll move back to the answers now. There were lots of different triangles that you actually could have worked in. So if your layout was a bit different from mine, it's fine. To find n though, there was only one way to do that. And this one was a bit more difficult too. Only the isosceles triangles that we have are like at the bottom of the circle, right? But here we actually had an isosceles triangle there. So OCD, that was actually an isosceles. So that's a radius and that's a radius, right? So because of that, that's where the angles of equal sides radii comes from, here on the side. Angle N is equal to, right? Those two angles. I don't think there was another way of getting in. Unfortunately, if you weren't able to spot that isosceles triangle, you would have been stuck in the rest of it. And then the next one would be E. So what I did was I saw that this is a diameter, right? COE is a diameter. So that would be perpendicular to the tangent. So that is 90 degrees. And then I worked in this triangle. Right? And I did, so I looked at that 60 degrees. I worked in that triangle and I did angle sum and triangle to get that 60. Right? 180 minus 90 minus 50. That's what I did to get that one. And then for the next one, I work with this triangle, get Q. So I saw okay, I have that 90-degree angle. Are we all okay with this angle being 60, right? Because if we look at this arc, that arc is subtending 60 degrees at the circumference. So at the center, it will have to be doubled at 60 degrees, right? So that's that part that I wrote there. Angle AOD, or you could have written OD, angle center. And then I did angle sum and triangle in this triangle there. Yes. So to get that back on the 30. So did you work out what that one is using angle and triangle? Yeah. Okay, I'm just going to move up a little bit to 18 because so it was 15 because it's kind of forward. So S was this angle over here. Sorry, I wrote the 50 degrees kind of over it. This was S. So we have tan forward there. Say that S is 50 degrees. And then we have to find R, which is this one up here. So I can see that this is an isosceles triangle, right? So if I have that angle there, I can do my whole 180 minus and then divide by 2. So if that angle is 50, this one is going to be 100 because of angle at center, right? And then if you know that the angle at the center is 100 degrees, you're going to say 180 minus 100 divided by 2. Because of that isosceles triangle, let's get off. And then you must just remember those 3 reasons. With angle from the triangle and angle of the equal side tangent. Okay, I think we'll mark 19, 20, and 21 next time because, you know, I can tell you quickly what the values are if you just want to mark your answers for the actual lessons. And then we can look at all the working tomorrow. So for 19, I got t equals 14 and u equals 31. Then for 20, I got v equals 70, w also 70, and then x equals 20. And then for the last one, which was 21, you just have to find y and z. I got y equals 84, and then z was 9. Yeah, I'll show you all the working for that tomorrow. For the rest of this lesson now, I'm going to give you more questions to work through. And you guys still have that target worksheet that we've done a few questions on before. And now, let me just check which one. Go to it here. I can't remember which ones we've done. Let me just check quickly. Target worksheet, first we did 1, 2, and 3. I remember we've done those two. And then we've also done like selected ones after that. 4, 5, 9, and 10. Okay, so that leaves 6, 7, 8, 11, and 12. 6, 7, 8, 11, and 12. But then I'm also going to give you 1 or 2 questions from the textbook because we do need to start getting into questions that are not just like find the size of this angle, right? Because where they're asking you other types of things. So I'm just quickly going to write down for you. Where is my remote? Yes, we are. Okay, target worksheet. What did I say now? It was 6, 7, 8, 7, 8, 11, and 12. And then in the textbook, so that is target worksheet ones are just like the ones that we did now, right? It's just finding angles. Then from the steps, exercise 6, which is on page 206, and I just want you guys to do number 2. So it's one diagram where you must calculate some angles. It's just working with tangents basically. And then they're asking you, is this line parallel to this line? Give a reason and this is how it is. I can put number 2 on the board for you, but the target worksheet I just hand out to you. It's difficult to put that on the board. Just quickly write that down so that you know what you are meant to be doing. Then I'll put number 2 on the board for you. Okay, you all have that? All right, that's number 2, guys, from the textbook. See if I switch the light on, a little bit clearer. But it looks hectic, but actually you just have to work with tan forward there. Right? That tangent, DE, is a tangent to the small circle and to the bigger circle. So you can use tan forward theorem to the small one. So for example, I think we can find a time to one order to work in the time first. So T is an angle between the tangent and the all that whole thing. That's the big circle. So the big 4 contains 54 digits. So C is going to be 54 is going to have it in a base circle, right? It's going to be 1. What is it? 18. You can do the target worksheet first. It's just when you're done with that, then you can, or you can do that one first and then the target worksheet. It's up to you. Yeah.